Hello everyone and welcome to our practice video. Before we proceed, I would like to remind you that you need to watch the introduction to trigonometry and the whole series about decreasing radians, which is the first subtopic of angles and angle measures. In this video, we're going to test ourselves if we have learned from these videos. All right? Don't worry. There will be actually another video for the second practice because in here, what we're going to do is we're going to write true, or rather, let's identify whether the given statements are true or not. All right. So let's now proceed. Oh wait, there you go. So we have the first statement. Trigonometry is about shapes that has more than three sides. So this one is actually easy. And if you don't know the answer here, then let's just say I'm disappointed, but just kidding. Basically, the answer here is false. All right? It's actually false. Why? Because recall that trigonometry is a study about triangles. All right? So a triangle consists of three sides. So when we say more than three sides, we're actually trying to imply, or we are actually implying that we're going to focus four sides, five sides, six sides. So no. All right. Rather, we're going to focus only a tree-shaped polygon, which is a triangle. So to answer that question, it is false. Next, angles are formed by at least two parallel lines. So what's your answer here? To answer this question, let's have a what do you call this one? A background information about parallel lines. When we say parallel lines, these are lines that do not intersect to each other, and they're actually how should I say this? Wait, let me rephrase it. First, they do not intersect to each other. Second, they go in the same orientation and direction. And third, they basically have the same distance away from each other. So for example, like this, all right? I have a first line, then I have a second line. These two are oriented horizontally. And as you can see, they do not intersect to each other. And at the same time, the distance from each point to the other correspondingly, like from here to there, here to here, here to there, they have all the same distance. So this is an example of having two parallel lines. It could be three actually. So for example, like this. Oh, wait. All right. And like that. All right. So there we go. So here, these are three parallel lines. Now, is it possible to form angles in these parallel lines? The answer for that is no. All right? No. Remember that in angles, if you're going to form them, you need two lines that intersect at a common point. Or if not lines, let's just say a ray, well, they should intersect at a common point. Like for example, we have this line, right? Then we have another line intersect to that. So here, if they intersect, they have a common point here, all right? Or the point of intersection. And with that, you can already form an angle, all right? Or you can form an angle from here, all right? As long as there's an intersection in a common endpoint, then you can have an angle. So to answer that question, it is false. Not question, statement. So to answer this statement, this is actually false. All right. So next, there are two ways on measuring angles, degrees and meters. So what's the answer? So if your answer is true, then that clearly means it's either you lack basics or you have not watched the video about degrees and radians. All right. So to answer that question or statement, I'm sorry, it is false. Why? We're going to have an answer of true, but there's actually wrong units here. All right. One wrong unit to be particular. We have degrees, which is basically like this. So for example, we have 30, then degrees. That's it. Then we have another one, which is rad or radians. So for example, we have 2 radians, or in a let's just say in a given quadrantal angles, let's just say we have 2 pi radians. So you see, degrees and radians. So the answer is false because we have degrees and meters, which is wrong. All right. So now let's proceed to the next question. So next is this. 1 degree is 1 out of 360 of a complete rotation. So is this true or false? The answer is it's true. All right. It is true. Why though? All right. Recall, based on our discussion last time about degrees and radians, which is, I do believe, it's the part 1. 1 degree, all right, is equivalent to 1 out of 300, 360 of a complete rotation. All right. So that means if you rotate until 1 degree, regardless of what rotation you use, that means you complete 1 out of 360. All right. So let's just say another example. Let's just say you rotated, let's just say 180 degrees. Remember that 180 degrees, it's here, right? So if you start from here, going there, you will form 180 degrees. So what does that mean? So 100 degrees is equivalent to 180 all over 360 of a complete rotation. By the way, I forgot to include the word rotation earlier. All right. So let me just put rotation here. All right. So once again, 180 out of what? Complete rotation. Or we can simplify this fraction. All right. 180 and 360 are both divisible by 180. So 180 divided by 180 is 1. And 360 divided by 180 is 2. So with that being said, we can simplify of having this fraction as 1/2. So in other words, 180 degrees is equivalent to 1/2 of a complete rotation. In other words, you just rotated halfway. All right. So yeah, that is all. So what's next? Wait, let me just erase this one. All right. So next, in radians, we will find the angle by dividing the radius of a circle by the length of the arc. All right. So let me repeat that. In radians, we will find the angle by dividing the radius of a circle by the length of the arc. So is this true or false? So if your answer is true, then you're wrong. Why? Isn't that it's actually correct? Recall that if you want to find radians, all you need to do is basically divide S, or basically, this is what? The arc length, right? Or length of the arc, all right? In other words. Then, divided by R, which is the radius of the circle, all right? So, when we say arc length divided by the radius, it should look like this one, all right? And that is how you find the radians. However, in this case, it's basically dividing the radius by the length of the arc. So meaning it's actually the opposite. We put R or radius on the top and S the arc length below. So this is wrong. This is not how you find radians. You should rather use this. All right. So if you want to make the statement true, then the answer for this one is dividing the length of the arc by the radius of a circle, not dividing the radius of a circle by the length of the arc. All right. So in other words, the answer for this statement is false because it's actually opposite. So next, degrees and radians are related to each other. Is this true or false? The answer is true. All right, this is true. Why is it true? So degrees and radians, they both measure angles, right? And because of this one, they're actually similar. Like for example, 90 degrees is just the same as pi all over 2 radians. 360 degrees is just the same as 2 pi radians. You see, they're actually related to each other. All right? Because these two are actually the same despite the difference between them in terms of the units and numbers. All right? In fact, since they are related to each other, we can convert a degree to radian or radian to degree. So to answer this statement, it is true. All right? So now let's proceed here. We will exactly have 1 radian when the given arc length and the given radius, the radius here is a circle, all right? Radius of a circle. Anyways, when the given arc length and given radius are equal to each other. So let me repeat that. We will exactly have 1 radian when the arc length and when the given arc length and given radius are equal to each other. So what is your answer here? So the answer is true. Why though? So recall earlier that if we're going to find the radian, we just basically what? Divide the arc length by the radius. All right? So assumingly that let's just say your arc length and your radius are the same. So let's just say your S is let's just say it's 3 meters and your radius is 3 meters as well. So with that being said, we will have 3 meters divided by 3 meters. So it's like you're dividing a number by itself. So you will have exactly 1 radian. So therefore, the answer is true. All right? Even only if the arc length and the radius are equal to each other. So yep, there we go. And actually, that is it, guys. So that is our first practice video. And we will now proceed to the second practice.